In this last video, we're going to take a look at the last section in our results section, which is the actual multiple regression analysis, which is where we actually answer our research question. We want to see if these predictors are significantly associated with our dependent variable. Finally, each of the output tables and the regression was interpreted in order to determine whether my hypothesis was supported. So we're going to run our multiple regression analysis, regression, linear. We actually ran this a second ago in order to get the predicted residual values to test our assumptions. We were satisfied that our assumptions are met. I'm going to go ahead and run it again. I'll turn off the save value so we don't create a bunch of unnecessary variables, and we'll run this analysis. So these are the three tables we're primarily interested in. We'll start with the model summary table, bring that over, and paste it into our lab report. Okay. So the R-squared coefficient is the key piece of information we're looking at here. In this case, it's 0.379, and we'll round that to 0.38, always rounding to the hundreds place. What does this mean? So R is a correlation, or the strength of association. So 0.62 is the correlation between the predicted values of the model and the actual observed values. We square that to get R squared, the coefficient of determination, and this tells us the amount of variation in our dependent variable predicted by the model. Okay, so this means that 38% of the variation in children's prosocial behavior was predicted by the model. Now, if 38% was predicted, that means that 62% was not predicted. I got that by taking 100, subtracting 38, leaves 62. This means that 62% of the variation was not predicted by the model. Now that seems fairly obvious. Why would I mention that? Well, I'm including that in our lab reports and in the results section here to help you get a sense for why you're still seeing all the residuals, all the variation in the scores between the predicted values and the actual values. The model isn't accounting for everything. It's only accounting for about 4/10 of the variance. We're also supposed to address the issue of substantive significance. So is it explaining enough of the variance to actually for it to actually matter? And in this case, we would definitely say that it does. If you're predicting more than, gosh, even 20 or 30%, that's substantively quite significant in the behavioral sciences in most situations. If we were predicting 3% or maybe 4% of the variation, we might wonder if the model was worthwhile, even if it was statistically significant. So this was substantively significant. Okay. So moving on to the ANOVA table, we'll go ahead and copy this and bring it over into our report. There we go. Okay. There we go. Okay, so the F statistic was, and let's take a look at it right here. So mainly we're interested in the significance of the F statistic. In this case, it is 0.000. So since it is less than 0.05, this tells us that the overall model results in statistically significantly better results than predictions based solely on the mean. It's an omnibus test of the entire model. So the F statistic was statistically significant, and we can go ahead and report this this coefficient, the F statistic, using APA formatting. So it's an F statistic, degrees of freedom between, which is 2. Within, which is 37, equals 11.29. That's a very high value. P, there we go, is less than 0.001. Okay, so so that's our F statistic. It is highly statistically significant, indicating, right, that the model results in significantly better predictions than those based solely, there we go, on the mean. Now, what happens if this is over 0.05? So if this is under 0.05 but under 0.01, we'd say P is less than 0.05 and so forth. If this were over 0.05, 0.06, 0.13, 0.24, what you would simply do is say the F statistic was not statistically significant. You wouldn't have to use this convention here. Just say it's not significant. The model does not result in better predictions than those based solely on the mean. So the model is not useful. You'll go ahead and finish your analysis here, but you'll make sure to report that and make it clear that you know that the overall model is not significant. Okay, moving on to the coefficient table. Let's go ahead and grab that. This is the most interesting of the regression output tables. Because it's going to actually answer our question in reference to these specific predictors. So you could have a situation where one predictor is significant and the other one's not, and this wouldn't tell you which one was. They could both be significant, one, the other, we don't know. But down here it actually gets into the details. So we're going to interpret the coefficient table and make it clear whether the hypotheses were supported. Okay, so let's start with that. So this table reveals that let's take a look first with the sex coefficient. So the unstandardized coefficient for sex is negative 0.9. So these are in standard deviation units. In this case, boys are coded 1, girls are coded 0. Since it's a negative coefficient, that means being in the 1 group, i.e. being a boy, means that you're going to, the model predicts that you would have 0.9 standard deviation lower prosocial behavior. Okay, so is it statistically significant? We look over here in the significance column, we see that it is. Peer church support coefficient is 0.375. The predictors and standard deviation units, as is the outcome, so the standardized coefficient is the same. And this means that a 1 unit or a 1 standard deviation increase in peer church support will correspond to a 0.375 unit or standard deviation increase in prosocial behavior controlling for sex. So if you want to predict the outcome, if it's a boy, you subtract 0.9, and for every unit increase, you would add 0.375 here. Also statistically significant. Both of these at the 0.01 level. So how do we write this out? Okay, so this table reveals that sex is a statistically significant predictor of prosocial, why don't we say of children's prosocial behavior. On average, boys' prosocial behavior is 0.90 standard deviations less than girls' prosocial behavior. Okay. What else? Peer church support is also a statistically significant predictor of children's prosocial behavior controlling for sex. So even with sex in the model, we have a significant relationship here. Okay. Let's see here. We need to explicitly state whether the hypotheses were supported. So if I hypothesized that both of these would be significant predictors, then I would say that yes, my hypotheses were supported. So thus, my 2 hypotheses were supported. So when you are writing up your results section, think back to your original hypotheses and consider whether they were supported. Right? So if you thought both of these would be significant predictors, then they're supported. Your hypotheses could be partially supported. Maybe one coefficient is significant, the other one isn't. Or maybe neither is significant, and you thought they would be, so your hypotheses were not supported. A lot of times students will ask the question, if it's not significant, do I get a bad grade? Do I have to start over? No, you're fine. As long as you ran the analyses correctly and found the answer, no is an answer. Sometimes the question is no. The answer is no to your question, and that's fine as long as everything's calculated correctly. Okay, so the regression equation for this model is, so y hat, that little symbol on top there is a hat. The hat means the hat designates predicted values. So predicted values of y are equal to our slope intercept, which is 0.38. Okay, so again, I'm rounding to the hundreds place, minus, right, because the next coefficient is negative 0.90 x sub 1. So I'm going to put my x into italics. I'm going to use a subscript for my 1. So x sub 1 is the sex coefficient. I don't want the comma there yet. Plus 0.38, I'm rounding, and it's positive x sub 2. So I'll copy that over and make that a 2. That is not a 2. There we go. And then I want to add a subscript, and I want a comma where I'm going to interpret the coefficients. I need to explain what this means in words. So where 0.38 is the expected level of the expected, let's say, pro-social behavior score for, okay, so let's make sense out of this. So the slope-intercept is the expected value of y being pro-social behavior, when all the x coefficients are 0. Okay, so let's think about what that means. If x sub 1, which is sex, is 0, that means it's a girl, because girls are coded 0, males are coded 1. So we're going to say for a girl, and then what does it mean if x sub 2 is 0? Well, that's Pearce Church support. It's a standardized score, so if that is 0, it means it's average, who receives an average level of peer church support. Okay, so if you have a girl with an average level of peer church support, the expected level of pro-social behavior is 0.38. In other words, it's 0.38 standard deviations above average. If it's a boy, you would subtract, there should be a decimal right there, you would subtract 0.90. So if a girl, it's 0.38. If it's a boy, you would take 0.38, you would subtract 0.90, which would give you negative 0.5. So a boy who receives an average level of church support would be about half a standard deviation below average in respect to their pro-social behavior. Okay, controlling for sex, a 1 standard deviation increase in peer church support corresponds. Notice I said corresponds to and not causes. This is a correlational model. We can't imply causality, but we can at least see if it's consistent with a causal theory. A 1 standard deviation increase in peer church support corresponds to a 0.38 standard deviation increase in prosocial behavior. Okay, so that's how we would make sense out of this coefficient table. Both of these are significant. So on average, boys have lower prosocial behavior than girls, and whether it's a boy or a girl, the more connected they are to the peers of the church, the more likely they are to exhibit more prosocial behavior. Your results section will probably be something along these lines in terms of making sense of the equation. If you're using sex in yours, or you're using maybe born again status, you would interpret this along the same lines as I did. If you're using one of the other variables, ethnicity or religion, you're going to have multiple dummy variables, and you'll have to interpret each one separately, like you did in the lab assignment for when you learned how to do dummy variables. Remember that 0 would be your dummy group, your reference group, excuse me, your reference group. So with ethnicity, if your reference group is Caucasian, then this would be the expected value for a Caucasian, right? Because that's all the dummy ethnicity variables are 0, with an average level of whatever your other predictor is. Okay, hopefully this is helpful to you. When you're all done with your results section, you'll save that, upload it to Blackboard. It does need to be submitted by the end of the week. For every day it's late, you'll lose 10%. So you want to get right on that. You want to give me time to give you feedback. If there are significant problems, you want to, or even small problems, any problems at all, you want to fix those before you turn in your final project. Please be very careful with the way you interpret your coefficients. I'm always keeping my eye out for interpretation errors. So if you were to look at this and say, oh, neither one was significant, that would be a problem. Or if you looked at this and said, oh, boys had higher prosocial behavior, or church support was corresponding to lower rather than higher levels of prosocial behavior, that would be problematic. You would lose a lot of points for that and possibly not pass the assignment. So make sure you keep an eye on those as well.